Today we'll be talking about the last rule of our exponent rules today, which is negative exponents, which we can move across the fraction bar. So as you can see in the first example, when I have d to the negative second power in the denominator, I can choose to move it up and make that exponent positive, which means that I can multiply like bases and add their exponents. Now I can also choose to go back to rule number 3 and just use subtraction when I see division of like bases as well. So that's where I'm getting the r to the negative third minus 1, p to the 8 minus a negative 2, and then times q. Then from there, if I do still have anything that has a negative exponent, it needs to move to the proper side. So if it's negative on the top, it needs to move down. If our exponent is negative on the bottom, it needs to move up. Okay, so it doesn't matter to me which way you use. You can choose to do either. You can choose to just switch back and forth depending on how you feel. But really you just need to understand that you can do it two different ways. So like on this one, I can move my x to the negative third up and then add those exponents of 1 plus 3. And that gets me the final answer of negative x to the fourth times y to the fourth divided by 5. Okay. So let's do some more simplifying here. So I see that x to the negative third is on the bottom, so I'm going to move it up. And then I can also reduce the fraction of 2/4 to get 1/2, and then add those exponents to get x to the 7th divided by 2. Okay, or I can choose to use the rule number 3 and subtract all those exponents to each other. Now when you do that, that moves them up to the numerator, and then if it's decided that they're still negative, then that's when you'd move them down. So like in this case, w to the negative 6 is negative, so I'll move that down to the denominator, so I get y to the 5th times v to the 6th divided by w to the 6th. Okay, now we're going to combine all 5 rules at the same time. So here I see rule number 2 in the denominator, so I'm going to distribute the 3 through to each one of those exponents. Remember, the negative 5 has an exponent of 1, so that's why it gets an exponent of 3, so 1 times 3. And then I can simplify the negative 5 cubed to make it a negative 125, and then I can use my different rules. Notice that q to the third has nothing to kind of go with, so it just stays in the denominator. And then here, I can simplify my fractions. I notice that h is still to the negative 5th, so it needs to move down. So my final answer would be 2 divided by negative 25 h to the 5th q to the 3rd. Okay, moving on to number 2. I see that I have rule number 2 again. So I distribute that exponent of 3 to the things inside the parentheses. And here I can do the same thing by subtracting my exponents. So that now I can move that q to the negative 14th down. That gets me negative 1/8 to the 10th divided by 5 times q to the 14th. That would be my final answer there. Okay, number 3, I see a rule number 2 again. So I distribute that negative 5 in the denominator to the exponents of c and b to the negative 3rd. Then from there, I can simplify. Here, 4 divided by 2 gets me 2, so I can just write that as 2. I can use the division rule to help me get those simplified. I still have a negative exponent, so I'm going to move that down. And that gets me 2c to the 8th divided by b to the 11th. Okay. Here I only see one thing that needs to have a distribution of an exponent to another in the denominator. I see that r is to the 0 power, so I can get rid of that if I'd like. Here I can just move the r to the negative 3rd down and the a to the negative 2nd up. And then because I'm multiplying like bases in the numerator, I can add those exponents. And that's going to get me 3a to the 11th divided by negative 4r cubed. Okay, have fun.